Okay, so this is going to be a weekly review, and we're also going to be adding some stuff. First thing I just wanted to just quickly go over was our update to the collision.js file inside of our engine. Um, so inside of our engine, and we go collisions. We have an in collision, but now we also now have a in collision point game object. This allows us to do something like, for example, raycast and stuff like that. So um, we can call collision kind of some pseudocode here because I don't have anything that would need this. Um, but what you do is you would call collisions.raycast, and for example, you could do your mouse position. So it'd be input.mouse, and we can double check. Yep, mouse position. And basically, what this will do is it'll say, hey, every game object in the UI layer and has a polygon component. You can also have it make it be a collider as well. So um, it depends what you want. To match Unity, collider is more practical because um, it obviously needs to detect collision. So, but and then what you do is you just say, hey, if the collision is in the if the collision with the game object of the mouse point is in collision with any of the game objects using this in collision point game object. And if it is, then we just return game object. Um, Say for example, you have a button. This would be the best way to see if it's on-clicked. So if it's clicked, then you could do this. Some sample pseudocode, but you would just put this inside of an if statement and then say something did happen. Then what you would do is simply say some of the sorts like um this dot get component polygon dot fill style equals gray or something like that. And if you do that, then it will change it to gray whenever your mouse is hovering. And then you could also then expand this to say, hey, and um, we also need to check if your mouse is down. So um, you would say um, input dot buttons down dot includes one, because if you're doing a right click, it's one. Um, I think. Um, so um, yeah, so that's one way to do it. This will allow you to do raycast. So what this would be basically saying is that if you're in collision with your mouse and you are clicking down, then you change it to gray. Um, so this could be used for buttons. You could also use this for many games have like a mouse input where you spawn something on your mouse. You could do something like that. Um, there's a lot of things you could do. Um, but and then there's something. Okay, that's better. The next thing that I wanted to review is our update to time.js. This isn't the full expansive one, but we did expand it a little bit. We have a static time now. That is the time for the total game. So this is time between scenes and that stuff like that. And then we also have a static frames variable, which just keeps track of your frames. Both are called in the static update function, where you add your delta time and your frames. And then inside of your engine, inside of game loop, we do time.update. One way to do this is if we actually look at our time variable, we search for time dot time. I have a destroy timer that we implement, I think, last video. And what I do is I just say, hey, in the start, I say, hey, this dot current time equals time. If the current time passed is greater than the current time from when we started plus the time when destroy, you destroy the game object. It's simple, but it's just rather than having a time variable in every single component, you can kind of reference the time update or the just one variable. Some downsides, or like sometimes where it's not as clear cut, is when you're going from like a cooldown, for example. Cooldowns, you'd probably need your own timer. And then another thing would be is in my player controller, I have the cooldowns, which you can put it on a timer. It's just a little weird. I think it makes more intuitive with how we currently do it. So I'm not replacing it with a built-in timer, unless I find a better way to do it. But there's some things where you don't have to use the time.js file. You can just reference it and like add current time manually. The next thing is collision layers. So inside of our game properties, now I expanded the layers. I have a platform, player, enemy, projectile, and health. There's a couple things to note about collision layers and layers in general. But what's happening is we're basically saying, hey, if player and enemy, the game objects on player and the game objects on enemy can collide with each other. The game objects, projectile and enemy can collide with each other. Platform player, platform enemy, and platform projectile, those can kind of collide with each other as well. There's a couple things to note about this. So one, for example, is if we start it, I changed the colors, which is kind of the main thing we're going to talk about today. But as you can see, there's like health bars and that stuff. But if I move the health, I was having issues with displaying the health there. And that was because if we put the health right here from, I was having trouble displaying the health. And I think what was happening was that if we go to our prefab health bar game object, and it is on this layer. Nope. Then I don't know. This is on layer 2. Oh, that was the issue I had. So if a layer doesn't exist, then obviously it doesn't get drawn. So just make sure you keep track of everything, and it should work. What else? Overall, this will actually help with a lot of optimization stuff. So some things you can do is just restrict game objects to only be able to collide with other stuff. So right now, enemy cannot collide. Like one thing we could test actually is something like this. So if we go back to our scene, main scene, and let's make it enemy 4. Enemy 4, enemy 4, enemy 4, enemy 4. 24, 24. And the only thing we need to do is change this parent. Um, let's do 400, 460. I think that will show the enemy up. So obvious, um, that's so obviously one thing you see is that the actual enemies don't collide with each other. So now enemy one can pass through enemy two with relative ease. There is no need to actually worry about anything of that sort. Um, this can be good because obviously we don't want enemies to be colliding with each other and dealing damage to each other and that stuff. So now having something like this just allows it to be a lot easier to actually manage. Because now you don't have to say, hey, if I collide with enemy, then if enemy collides with the enemy, then you don't do this or that stuff. You just ignore collisions between enemies altogether. And then boom. So now it's like that. By implementing collision layers. Um, the final thing is inside of our game object. Inside of our game object.js, we now have a find by tag and a tag as a no tag to begin with. If we Google or not Google, do a search, I actually used it once, and so what I'm currently doing in this is in my start scene controller. What I do is I filter or I tagged these game objects to now be able to display or to show, hey, this is where the arrows can go. Um, and it just allows you to index it and filter those specific enemies rather than it being static. So if I adjust or add a new one, all I'd have to do is add a new index, basically. Um, some other examples could be if you have do like a Fire Boy and Water Girl game where you have like a W, A, S, and D, and then your arrows to control one, and then the WASD to control other. You could tag both of them as players, and then they would have the same functionality as players. So if you collide with something, you could say, hey, if it's a player, if the tag has player, then do this. Other examples would be a lot of games have multiple enemies, but they all kind of interact with the same. They just do like stuff on top of it. So like all enemies should, or most enemies should be able to apply damage, or all enemies can apply damage, and maybe that's just zero damage. Well, what you could do is you could say, hey, if the tag has an enemy, then you get to, or if the thing you collide with has a tag named enemy, well, all enemies will have this damage controller.js, which determines how much damage they do. It's just another kind of layer of abstraction that allows you to be more dynamic with stuff and like less code, hard coding stuff. Because if there are three different types of enemies, you would have to say, hey, if I am damaged by enemy one, do this, enemy two, do this, enemy three, do this. You could just do a tag. So um, the next major thing that I am doing outside of class is that a lot of students actually were wanting um, effects. So one example, when I kill the enemy, it fades away rather than actually just being instantly destroyed. That was a common one. Another one is that when something is damaged, it flashes red. And then another thing would that in this game specifically is if I damage, that text just spawns in instantly. It's there or it isn't. You could even have that fading text that would also be good. So that's what we will be doing today. I made changes off screen because the way we have to do this is do a major change to our polygon component, the easiest change would be to inside of our components polygon, I got rid of fill style. Fill style is best for um, static colors. With what we're doing, we need to have variables that control our fill style. So technically, what you could do is you could say, hey, this dot fill or fill style equals magenta. And then you could say this dot fill style equals red, green, blue, what we do here, and then you just set equal to fill style. But I decided that wasn't worth it. It was not really important. But so the thing that we will be doing is we will have 4 variables that control our R, G, B, and this opacity and forth. Many people use just RGB, and that'll just give you the red, green, blue values, but RGBA gives you this fourth value for opacity. And this allows us to do a lot of fading out types of things that we want to do. So the next thing we need to look at is how, let's do damage text, for example. So what I have, let's look at the components first, actually. So I created this the fading controller. And there's a couple things that we want to do with the fading controller. Obviously, let me go back to basic enemy and let's uncomment this because let's focus on the fading or the damage text. We have a is fading variable that is always false, or we assume it's false. We have a duration left and a total duration, which is set to 0. And then we have a polygon component that we need to find. My idea on how this should work is that, say for example, we first need to check if this fading is true. If this is fading, so this will say, hey, if you're fading, then you can kind of do your fading activities. And what we want to do is we want to do we have a fading current duration left. So what we want to do is we just want to set this dot fading current duration left minus equals time dot delta time. We have to do this because it would be hard for a timer or to use the time class in order to actually kind of implement this. Then what we want to do now is we just want to get this polygon component, this dot polygon component, and we can just do dot opacity equals, and then we want to do math.max because we only want to get the biggest one, and we scale it based off of this dot fading current duration left divided by this dot fading total duration, and we compare that with 0. What this will do is it will just say, hey, we said equal to the percentile of the opacity or the time left or 0 if it is somehow gets negative or there's an error in here. One thing to note, opacity is not not regularly 0 to 255 value like RGB would be. Opacity is from 0 to 1. So this is why it works, because we're just getting a percentage of duration left and a percentage is from 0 to 1. And then inside of the start, what we need to do is we just need to get the polygon component. You would do equal this dot game object get component get component polygon. But here's an issue. it's not our text, for example, isn't a polygon, it's a drawing. So when we look back at our polygon component, it wouldn't be on this damaged text that we would have. The one thing we also need to do is implement the red, green, blue, and opacity for the text as well. This will allow you to also do it for text. So how do we actually do this though? Because we want the polygon component, we want this component now. It's not really a polygon component. So we can rename this to the draw component. And we want the draw component to equal the polygon component if there's a polygon component, or the text component if there's a text component. So what we would actually do is we would use this operator where we do a double question mark, and then we can do this dot game object dot get component. I don't know the name for this, but what it basically does is it says, it's kind of like a condensed if statement. It says, hey, if this is true in a valid lookup, use this first value that you have to fill in the draw component. If this is false, try this.gameObject.text, and then it will use text instead if the polygon component isn't there. It is a kind of equivalent to just, I can pseudocode it. Like that. You basically say if the first value, we just say let value equal 0. If first value, and what you do is you set value equal to first value, else value equals second value. So that's kind of just the sum of it. Now what we have is we get the polygon component, or more like the draw component, and then we check if it's fading. If it's fading, then we update the opacity and the time left. And then we kind of want to change this now, and since we want it to fade all the way to 0, what we actually need to do is we need to see if our draw component opacity equals 0. And only once it equals 0, then we do this .gameObject.destroy. DSTR. What this will do then is it will destroy the game object when it just hits 0 opacity. So it doesn't take up anything else and remove it from the list, so it doesn't have to update and draw all these components. Let's start fading. What we want to do is we want to do this dot is fading equal to true. So we need to turn that switch on. And then we need to set this dot, we need to set these two values equal to the fading duration so that we can get the percentages. Now, if we want to destroy something to begin with, or once it spawns in, that's where we do this, where inside of our game object, what we do is we would set is fading to true, we would set fading current duration and fading total duration equal to each other. One caveat you could always do is you could then set this dot total duration, this dot total duration equals this dot fading duration left. And then we could just set this dot fading total duration, just as a kind of a easier way to do it. And now what will happen, hopefully, is that when we go into here and we go to, let's do sniper. And if we hit on it, it does not fade. Let's do this then. If that. Maybe we can't do that. Hyper. See. That's at max. Let's debug it. Do this. Let's go up here. Let's do console source fading controller. Let's get this to make sure that it is correct on what it is getting. So the draw component is text. Let us now do there. We continue. This dot is fading is true. 2 seconds left. So we go over here. This dot draw component dot opacity. Oh, I see the issue. They are both fading direction left rather than. So now if we go sniper, we go there. Now we see that it fades, and then once that opacity gets 0, then it gets destroyed. What else? So now that we have this, now we can apply it on other things. Obviously, the next thing that would be obvious is the fading controller for the basic enemy game object. We want the enemy to fade out rather than just instantly disappear. So the thing we would do is we would go back to our where's that? Enemy controller. Let's think. So I would go. So one kind of good thing about having a pool system is that, and only apply damage through a function, is that you can do specific stuff um, when you want to apply damage. For example, the health pool controller will always be on enemy game objects. We can. So what we need to do now, if since we're fading enemies, is that well, we could do this instead. So inside of the health, this dot current health H, when we apply damage and we set the current HP to 0, rather than fade doing the just destroy automatically, let's establish the fading component. And that equal to this dot game object dot get component fading controller. And now we could do an if statement. We could have done that previous operation, but I have tested it and it seems to not be relatively working. But what we want to do now is if fading component does not equal null, so obviously there's a fading component. What we want to do is we want to do fading component dot start fading, and we want to set a duration of 0.5, else we destroy this game object. So now hopefully if we go back to our game and we do our sniper and we do my 2 shots, now the enemy fades. But if we test some stuff, so let's go to sniper again. It was hard to see, but obviously I'm half HP. One thing to note is that we can still technically collide with enemies. So we go there. We can still collide with fading enemies, and that can cause some issues. Um, so one thing that I always do is um, actually since we didn't take damage, I think that's fine. Um, but inside of enemy controller, the reason why we don't take any damage is because now we have this opacity equals 1 restriction that we would need. So if we got rid of that and we went back to our game, um, and we destroy it, that was close. So let's do sniper again. There. So obviously, it was destroyed. It was hard to see, but I destroyed it by firing again, and I still took damage based off of this like fading away ability. So that's why what we need to do is we need to actually make sure that the enemy can only apply damage to player if the opacity is 1. Um, what else? So now the and another thing, since if we go to our player game object, we don't have fading. So what will happen is if my player gets destroyed, obviously we saw that earlier, but nothing happens. It just instantly gets destroyed because it just says, hey, there's no fading component, so just destroy it when health equals 0. Now, let's do this hit effects controller. With this hit effects controller, there's a couple things that we could be thinking of doing. For example, a common thing is that flashing red. So that's why I have that is red variable and that red timer up there. Whenever I hit something, I want it to flash red for a good duration before changing back to its original colors. So what I can do is I can say this dot polygon component. We always need to get that for this now. Dot game object dot get a component polygon. We want to set the original red equal to the this dot polygon component dot red, and we want to do the same for green and blue. Original red, original green, and blue. And what we want to do is it is as simple as, hey, if where this dot is red, if we are red, um, this dot red timer minus equals time dot delta time. And what we want to do now is we want to get the this dot polygon component dot red equal to 255. We set green equal to 0, and we set blue equal to 0 as well. And then inside of the if statement, it would just be as simple as if this dot red timer is less than or equal to 0. The next thing we want to do is we just want to say, hey, this dot red is red equals false. And then we want to reset it back to the original colors. So we would copy and paste this. And we would set it equal to the original red, original green, original blue. And for the hit effect duration, it would be something as simple as this dot is red equal true. This dot red timer equals duration. Okay. So now if we go back to our health pool controller, now what we want to do is whenever we apply damage, we want to see if this dot game object dot get component hit effect controller, and then we want to do the Elvis operation, and then we do hit effect, set hit effect equal to 0.5. So if we go back to our game, and then let's go back to a basic enemy game object. As we see, we have this hit effect controller, and our player game object does not have that hit effect controller. So, and they both use the health pool game object and system. So if we go back to our sniper and we hit them, they are now red for a period of time, but I am not. And as you saw that when they were fading away, they also faded as red. We do that. Obviously, this is a very dynamic system because you can always set it equal to 0.25, for example. And then we go back to our game, and it is more of an instantaneous. You can even go to 0.1. And yeah, so that's kind of one of the things you can do. I think that kind of sums up what I wanted to do today. Just a lot of little stuff from reviewing, and then kind of one core thing that can be applied in many different ways. So now say you wanted to do an explosion when a game object dies. What you could do is you could really you could follow this this fading. Where's you can follow the logic for here, where if you could say, hey, you could have a component where it could be on death controller or something like that, and you can give it game objects to run when an enemy dies. So say for example you're doing Galaga and you want to do the ship explosion when you destroy a ship. What you do is you would just then have an invisible game object, or you could have a whole new game object not instantiated yet. And then rather than saying, hey, invading component dot start fade, we would do instantiate new explosion game object. And then we could actually then adjust and then you could have a fading or an explosion component or controller, and it slowly fades away after a distance of time, so that it's just not a static. It's all gray and then it's none. It could be a fading out into white, or there's just a lot of things you can do. This will this by doing this, you could just bring a lot of aesthetic to your game. And there will be more stuff in the future that can do that as well. There are some things like particle systems that we will be attempting to cover this semester that will even just bring more aesthetic to your game, and for those those more like game effects rather than the core gameplay. I think that's it for my video. My email is on syllabus if you need to talk to me, or you can always talk to me after class if you have any questions, comments, concerns.